Still in section 3.7, we are asked to graph some rational functions. So let's do a couple of examples of those. The first one we're going to look at is problem 35. And the first thing you really should do with these is to figure out what all of the asymptotes are equal to. So in this case, to find the vertical asymptotes, again, we set the denominator equal to 0. So in this case, that means we have a vertical asymptote at x equals 0. Then we want to figure out what's going on with the horizontal asymptote. Well, if you were to multiply the numerator out, go ahead and FOIL that out, you get x squared minus x minus 2. So then the numerator has degree 2 and the denominator has degree 1, which means the numerator has a larger degree than the denominator, so then there are no horizontal asymptotes. But since the numerator has a degree exactly 1 more than the denominator, there will be a slant asymptote. So let's figure out what that is. We can use long division. So we take our denominator, which is just the x, and divide that into the numerator, which is x squared minus x minus 2. All right, so x squared divided by x is x. X times x is x squared. And we subtract. Well, in this case, the x squareds cancel out, and we bring down the negative x. Well, negative x divided by x is negative 1. Multiply, subtract, and what we'll end up with then is that the slant asymptote is y equals x minus 1. Let's go ahead and put those asymptotes on our graph. So I have a vertical asymptote of x equals 0, which means a vertical line that is right over top of the y-axis. And then I've got a slant asymptote, y equals x minus 1. So that means we have a y-intercept at negative 1 and a slope of positive 1. So it goes up 1 and over 1. So then I have this slant asymptote. Now an asymptote simply means that as you go toward infinity, your graph will get closer and closer to the asymptote. So what we need to do is figure out where is the graph going to be. Will it be in this section and this section, or maybe these two sections? So we need to plot a couple of points just to see where this graph is going to land. So I'm going to just draw a small t-chart. I really don't need to plug in a lot of points. I'm just going to use negative 1 and positive 1. I just need one thing on the left of the vertical asymptote and one on the right of the vertical asymptote. So plug negative 1 into this function. Negative 1 squared is positive 1. Minus a negative 1 is the same as plus 1. So positive 1 plus 1 is 2. 2 minus 2 is 0. And then 0 technically over negative 1, which 0 divided by negative 1 is still 0. Okay, plug in positive 1. Well, 1 squared is 1 minus 1, so 1 minus 1 is 0, minus 2, so your numerator is negative 2, but your denominator is 1, so that doesn't matter, so negative 2 divided by 1 is negative 2. So I can plot the point negative 1, 0, and I can plot the point 1, negative 2. So then I see that as I go to infinity, my graph is going to get closer and closer to these asymptotes. So I end up with a graph that looks something like this. Let's also look at problem number 37. Problem 37, similar instructions. We're asked to graph this particular rational function. In this case, it would actually be a good idea to go ahead and factor the denominator and see what happens when we do that. So the denominator factors into x plus 2 and x minus 2, which then we see that the x plus 2's could be canceled out. So this function is almost equivalent to the function 1 over x minus 2. And I said almost for a reason. We'll see why in just a second. Okay, vertical asymptotes. Well, if you're looking at this simplified version, we set the denominator equal to 0, which gives us a vertical asymptote of x equal 2. Horizontal asymptotes, well, the degree of the top, there aren't any x's at all, so it's technically degree 0. And the degree of the bottom is 1, since the largest power of x is 1. So the bottom, or the denominator, has a larger degree than the numerator, which automatically makes the horizontal asymptote y equal 0. Okay, so I've got my vertical asymptote at x equals 2, and I've got a horizontal asymptote at y equals 0, which is right on top of the y-axis. All right, so once again, I really only need to have 1 point to the left of the vertical asymptote and 1 point to the right of the vertical asymptote. So I'm going to draw a small t-chart here and plug in a number to the left of 2 and another number to the right of the number 2. Let's just go ahead and use 0 and 4. So if I plug 0 in for x into this simplified version, I end up with a y value of -1/2. And if I plug 4 into this simplified version, I will have a y value of +1/2. So then I want to plot those points. So 0, -1/2 is going to be right about here. And +4, +1/2 is going to be right about there. Now, here's the problem though. We also canceled a factor back here. We canceled a factor of x plus 2, which I should not allow -2 to be plugged into this function because of the fact that it was not part of the original domain. So on my t-chart, I'm going to add a value where x is -2 and plug it into the simplified version, and I get -1/4. And what I need to do with that point is to not make a solid dot out of it, but to make an open dot out of it, just to show that there's a hole in my graph because I'm not allowed to plug in the number -2 because of the original denominators having that factor of x plus 2. Okay, so again, on this side of the graph, I'm going to hug the asymptotes as I go toward infinity in both directions, as well as on this side of the graph, I will get closer to the asymptotes as well.